Hi, welcome to this video. In today's video, I'm going to look at a very interesting series. I'm going to work on the Maclaurin series for the function natural log of 1 plus x and natural log of 1 minus x. Okay, so I'm going to do the Taylor expansion. So the general expression of the Taylor series, which is f of x, which is f of a plus the first derivative function at the point a over 1 factorial multiplied by x minus a, okay, plus the second derivative function at the point a over 2 factorial multiplied by x minus a quantity square, and so on, all the way down until you get the last term. Okay, so I'm going to tick until you get the last term, which is f of to the n at the point a over n factorial multiplied by x minus a to the n. Okay, so now what I'm going to do now, take the case a equal to 0. So I'm going to set f of x equal to natural log of 1 plus x. Okay, so I'm taking as a special case a equal to 0. Okay, so f of x equal to f of 0 plus f prime of 0 over 1 factorial multiplied by x plus second derivative function at the point 0 over 2 factorial, and so on until you get the last term, which is the n derivative function at the point 0 over n factorial multiplied by x to the n. Okay, so what I'm going to do now, I'm going to take the first derivative function of natural log of 1 plus x. So I will have f of x equal to natural log of 1 plus x. So this one implies f prime of x, which is 1 over 1 plus x. Okay, so the second derivative function of natural log of x, which is minus 1 over 1 plus x. Okay, minus 1 over 1 plus x quantity square. Okay, so the third derivative function of the natural log of x, which is 2 times over 1 plus x to the 3. The fourth derivative function of this natural log, which is 1 over 2 multiplied by 3 with minus sign outside over 1 plus x to the fourth. Okay, and so on. So as you see here, f of 4 of x, and then the same thing here, you see 1, 2, 3, and then on the denominator you see the 1 plus x to the fourth as an exponent equal to the derivative function order. Okay, so the exponent of the denominator equal to the the order of the derivative function, but on the top, but on the numerator you see 1 multiplied by 2 multiplied by 3. That's mean the n derivative function of this function, it will equal to n minus 1 factorial. If you take a look at the derivative function of the order of the derivative function of this function, and then compare it with the last digit number of numerator, you see number 3, number 4 here. So that's mean n minus 1 factorial over 1 plus x to the n, right? So what I'm going to do now, I'm going to collect all these terms and put them together into one expression. Okay, now I will have natural log of 1 plus x equal to, so f of 0 of this one, if you plug the number 0 into here, is giving you natural log of 1, which is 0. I'm moving on to the next term, f prime of 0 equal to, if you plug number 0 into here, is giving you 1. If you plug number 0 into the first derivative function, you will have 1 over 1 plus 0, which is 1. 1 multiplied by x is giving you x over 1 factorial, which is x over 1 factorial. Let's move on to the next term. I'm going to plug number 0 into the second derivative function. I will have this one minus 1 over 1 plus x. I have minus 1 over 1, which is minus 1. So we'll have minus 1 here, minus 1 is multiplied by x squared. Okay, so we'll have minus x squared over 2 factorial. Okay, and moving on to the third derivative function. So if you plug number 0 into this third derivative function, we'll have 2 over 1, which is 2. Okay, so that's mean this 2, I will have 2 factorial, because this one is 2 factorial. Okay, this one is 1 factorial, because here this one is 3 factorial. Okay, so what happened here, minus x squared over 2 factorial plus this term, I will have plus 2 factorial over this one over 3 factorial, because the next one over 3 factorial. Okay, because this derivative function, if you this one over 3 factorial multiplied by x to the, okay, this one is multiplied by x squared, this one is multiplied by x cubed. Okay, so this one will have x cubed here. Let's move on to the fourth derivative function. The fourth derivative function will have minus sign here. So if you plug number 0 into this fourth derivative function, I have 1 on the denominator as a denominator. So we'll have minus factorial, minus 3 factorial over this. I'm going to plug this one into, after this one, we'll have 4 factorial is multiplied by x to the fourth, and so on until you get the last term. So the last term here, always will have if you plug number 0 into this function, we will have n minus 1 factorial, okay, over n factorial. So we'll have n minus 1 factorial over n factorial is multiplied by x to the n. Okay, so I'm going to simplify this one a little bit. So natural log 1 plus x equal to x over 1 factorial minus x square over 2 factorial. I'm going to simplify this one. 2 factorial, it will simplify with 2 factorial. I will have x cubed over 3. Okay, 2 factorial will become 2, 1 factorial will become 1. So the fourth term, I'm going to simplify 3 factorial from numerator and denominator. I will have minus x to the fourth over 4 over 4, and all the way down, okay, until you get the last term. Now at the numerator we have n minus 1 factorial over n factorial. I'm going to simplify n minus 1 factorial from numerator and denominator. So we'll have x to the n over n, right? I'm going to bring this one at the top. So the last step of this one, we were at natural log of 1 plus x equal to x over 1 minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4, and so on until you get the last term, which is x to the n over n. I'm going to put this one on the form of the sum. So I will have this sum minus 1 to the n. So I'm going to put this one on the form of the sum. So as you have here, natural log of 1 plus x equal to this sum minus 1 to the n minus 1 is multiplied by x to the n over n, as n goes from 1 to plus infinity. Now if you plug number 1 in the first term, so you will have 1 minus 1, which is 0, which is 1 minus 1 to the 0 equal to 1. 1, as you see here, if you plug number 1 into n, is giving you x, which is 1 over 1, which is true. As you see here, we have this sum. I can rewrite on the other form as well. I can change the order of this one as well. So I will have the sum of minus 1 to the n, as n goes from 0 to plus infinity, is multiplied by x to the n plus 1 over n plus 1. Now this is the value of natural log of 1 plus x. Okay, I'm going to evaluate natural log of 1 minus x. So it's not the big difference here. I'm going to just put minus x instead x. Okay, so I will have natural log of 1 minus x equal to this one, and put the sum as n goes from 0 to plus infinity, minus 1 to the n. I'm going to plug minus x inside this one, okay? We will have minus x to the n plus 1 over n plus 1. So if you take a look at here, this one equal to the sum of, so natural log of 1 minus x equal to this. I'm going to bring minus 1 to the n plus 1 outside of this one. I will have minus 1 to the n multiplied by minus 1 to the n is multiplied by minus 1 to the n plus 1 is multiplied by x to the n plus 1, okay, over n plus 1, as n goes from 0 to plus infinity. As you see here, I can separate minus 1 with the minus 1 to the n. With minus 1 to the n, which is giving us 1 multiplied by minus 1. So this one equal to minus the sum of x to the n plus 1 as x to the n plus 1 over n plus 1 as n goes from 0 to plus infinity, okay, with minus sign here outside. So this is the value of natural log of 1 minus x. As you see here, natural log of 1 plus x equals to the integral of dx over 1 plus x, okay? So we already found the sum. So this one, I'm going to put this one on this form, 1 minus x, okay? So as you see here, this is geometry series. So this one is written on this form, the sum of minus 1 to the n multiplied by x to the n as n goes from 0 to plus infinity, okay? So natural log of 1 plus x, I'm going to bring the sum sign outside of integral, okay? I will have minus 1 to the n as n goes from 0 to plus infinity. The integral of, this is dx, integral of x to the n dx, okay? So this one, as you see here, this is the sum of minus 1 to the n as n goes from 0 to plus infinity. This one is 1 over n plus 1 to the x to the n plus 1, okay? So natural log of 1 plus x equal to this sum, minus 1 to the n and multiplied by x to the n plus 1 over n plus 1 as n goes from 0 to plus infinity, okay? So we found this value by using both methods, Taylor expansion and geometry series, okay? So I have done with this problem. Thank you for watching. I will see you in next video. Bye.